Okay, all I wanted to do in this video was a little recap based on some questions that I saw on that Google form on the independent and dependent events. So when we have a independent event, all I want you to think about is that the events have no impact on each other. You have a dice and then you have a deck of cards, or you have a deck of cards and then you're flipping a coin, or the item is replaced back in. So the card is replaced back to the deck, the marble is put back into the bag. Those things we would consider independent events. Whereas for a dependent event, think that they do affect one another. So the item is not replaced back in. The card is not replaced back to the deck. The marbles are not put in the bag. So think about that when we have independent and dependent events. So just going through kind of a little bit of an example, very similar to what we did yesterday. So in that first one, suppose there are 3 white and 3 black marbles in a bag and you remove 2 marbles. What is the probability that you will select a white marble and then a black marble? But now think, we will replace the white marble. So since we're replacing the white marble, it's an independent event. Same thing in problem number 2, but now suppose there are 3 white and 3 black marbles in a bag and you remove 2 marbles. What is the probability that you will select a white marble and then a black marble? But now this time, you're not going to replace that first white marble. So since you're not replacing it, dependent. Now let's do a little bit of practice, very similar to what we did yesterday or the other day in that Edpuzzle. So if you draw a card from a deck numbers 1 through 10, someone's question was, why was I using 10? That's just what I chose. So when you get down to the first probability, it's going to be over 10. And then you toss a die. Find the probability of each outcome. So first one, 2 odd numbers. So for the deck of cards, you have 1, 3, 5, 7, and 9. And then for the die, you're just going to have 1, 3, and 5. So what's the probability of getting an odd number from your deck? Well, you have 5 numbers here, and there's a total of 10 cards, so it's 5 over 10. What's the probability of rolling an odd number? Well, you have 1, 3, or 5, and you have a total of 6 options, so 3 over 6. If you multiply the numerators together, denominators together, you get 15 over 60, and that simplifies down to 1/4. In problem number 2, what's the probability of getting a 3 from the deck and then a 3 from your die? So you're looking to get a 3. So that means you have a 1 out of 10 chance. Looking to get a 3 from your die, that's a 1 out of 6 chance. Multiply them together, you get 1 over 60. So hopefully this is clearing up anything that we might have with independent events. For dependent events, same type of problem we saw before. There are 4 red pencils, 6 green pencils, and 5 yellow pencils in a jar. Once a pencil is selected, it is not replaced. Find the probability of each outcome. So what's the probability of getting 2 reds? So all we're going to do is the probability to get a red pencil. Same problem before, so it's a total of 15. 4 over 15 is my starting. But now I have 1 less red and 1 less pencil. So this number should be 3 over 14. If I multiply them together, I got 12 over 210, and that gives me 2 over 35 when I simplified. So once again, this number, 3 over 14, is coming because you have 1 less pencil and you have 1 less red. Here, what's the probability of getting a green and then a red? So the probability of getting a green is 6 over 15 because there's 15 pencils. But now I'm not replacing it, so now there's only 14 pencils. How many reds? 4. Multiply them together, 24 over 210, and that simplifies down to 4 over 35. So hopefully this was helpful. I'm going to try to start our classes like this with little follow-ups based on what you tell me from your Google Forms. So we'll move on from here.